So the process for solving a system using matrices is basically reducing it to be in one of these two forms. So we have this thing called the row echelon form. And what you'll see here is that you have along the main diagonal, you have just ones. And then below that, you have zeros. Okay, this is okay, but if you can go a couple of extra steps and get to the reduced row echelon form, you still have ones along the diagonal. But in addition to having the zeros below that diagonal, you also have zeros above the diagonal. And the great thing about that is that it basically just hands you the solution. Because we said before that these would be the headings for the columns X, Y, and Z. So that means from this first row, that means that 1x is equal to 3. From the second row, 1y equals -2. From the third row, just 1z is equal to 5. You might say, what about x and y? Well, you didn't have any x or y in that last row. Now, in reduced or in row echelon form, like down here, you would have, from here, z equals -15. And then you use that value and you back substitute, and you can find out y and then x. Now, this whole process is called Gauss-Jordan elimination. So we're going to rewrite our systems using a matrix, and we're going to perform row operations on these matrices so that we can reduce it. All right, so let's take a look at this system right here. X minus 2y equals 2 and 3x minus 7y equals 4. Yes, I know we can solve this using substitution and using elimination. But what I want to do instead is that I want us to rewrite this as an augmented matrix. So, as an augmented matrix, this becomes 1, -2, the vertical bars for your equal sign, and we have 2 on the other side. Then we have 3, -7, and 4. Now, we're going to be performing matrix row operations on this so that we can get it into first row echelon form and then the reduced row echelon form. So, remember the things we've talked about before when we were dealing with using the elimination method. We can rearrange the rows and nothing's going to change in terms of our answer. Just like if I were to rearrange those first two equations, if I rearrange them like that, it's still going to give me the same answer. I can multiply any row or divide any row by any non-zero constant, and it's still going to be equivalent. Plus, I can add one row with a multiple of another row together and replace that row, and it's still going to give me the same thing. So let's watch how this goes. The first thing is we want to make sure that we have a 1 here in the leadoff spot. If not, we can rearrange the equation so that we do have a 1, or we'll have to divide by that coefficient. So right now we have a 1, which is great. So then here's what I'm going to do. I'm going to do -3 times this first row, add it to the second row, and I'm going to replace the second row with that. So this is how we kind of write out what we're doing. We do the steps, and then we actually perform the algebra for this. So the first row does not change, so we're just going to write that down. And now we're going to do the math that we have right here. So -3 times 1 is -3, plus 3 is 0. And then we have -3 times this guy right here, so that's going to be +6. Add to -7, we get -1. Don't forget about the constants. -3 times 2 is -6. -6 plus 4 is -2. So this looks like it's going to be okay. The next thing I want to do is, now that I have a 0 down here, I need this next piece right here. I need that to be a 1. It's a -1, so I'm almost there. So what I'll do is I'll do negative row 2 and just kind of replace that in row 2. Okay, so my first row is still the same. 1, -2, 2. This bottom one now becomes 0, +1, +2. We need to multiply everything times -1. This is row echelon form. But I want reduced row echelon form, which means, yes, I have ones along the diagonal. That's great. But I want to have zeros everywhere else, at least on this side of the matrix. So I'm going to get this guy right here to be a 0. And I do that by doing 2 times row 1, 2 times row 2, adding that to row 1, and that's going to be my new row 1. So my second row does not change. So with the 0 here, the 0 in that first spot is not going to affect anything above it when I start multiplying and adding, because you multiply 0 times 2 and you add it up to the top right here, that guy is still going to be 1. But now I do 2 times 1, and I add that to the negative 2. So now we have 0. And then I do 2 times 2, which is 4, and I add that to the 2, and that gives me 6. So we are now in reduced row echelon form. And this gives us our answer. It tells me that from this first row, x equals 6. From the second row, you just have 1 y, and that equals 2. So we have the ordered pair 6, 2. And again, what we have here is an algorithm. You force it so that once you get a 1 here in this first row, you kill everything below it. And then once you have a 1 in this next row as the lead-up guy, you kill everything below that, and so on. So this is going to apply even if you have 3, 4, 5 rows. You get zeros underneath the first one, zeros underneath the second one, and so on and so on. So you just have a bunch of ones along the diagonal, zeros underneath it, and then you work your way back up, killing all the other numbers until you have ones along the diagonal and zeros everywhere else. So you can clearly identify what your solution is. Now, we can do this in a calculator, but you got to make sure you follow the steps here for typing it into your calculator correctly. So all this is going to be under your matrix menu. So it's right here. So press second, matrix. So right now we have a bunch of named matrices, but they're all empty. They contain no entries. So go over here to edit, and we're going to edit the first one. So we have a 2 by 3 matrix because we have 2 rows, we have 3 columns. To make your life easier when you're typing things in, you don't need to use the arrow keys. Just type in your number, hit enter. Type the number, hit enter. So I've got 1, -2, +2, and then I have 3, -7, 4. You have to make sure you hit enter after this last one. So you see here in our augmented matrix, it's the same thing that we have on the notes. All right, now quit out of this, because if you start trying to do other stuff here, like doing some calculations, it's going to start typing it in the spot that you have right here. We don't want that. So quit. Go back to your matrix menu. Now matrix A is defined as a 2 by 3 matrix with those entries that you've typed in. Go to the right, and if you look at this, you have REF and you have RREF. It's the same stuff that I was writing on the notes. REF is a row echelon form. RREF is reduced row echelon form, which would basically just give you the answers, right? But I want you to see how this looks. If I do row echelon form of matrix A, so we come back here, grab the matrix, hit enter to select that, and it tells me that my row echelon form is, well, that's different than what I have. I think I must have typed something in to the calculator incorrectly. Let's see. 1, -2, 2, 3, -7, 4. Did I do something wrong? Because that is not the same thing that I have for my, I wonder. Now I'm just super curious. If I go math and convert that into a fraction, how would it... Oh, I think I know what it did. I think it swapped some rows around. Yeah. For whatever reason, and I don't know why, I can't explain it, but it seems like the calculator flipped my rows around. So the row echelon form is not the same as what I have. It's actually messier. But you know what? What will always be the same is when I go to the reduced row echelon form. So RREF of matrix A, and there we have 1, 0, 6, 0, 1, 2. That gives us the solution: x is 6, y is 2. Yeah, so I guess some of the row echelon forms can look a little bit different. I have no idea why I would switch those around, but the calculator has its own way of doing things. Right? It has its own algorithm. So the process that it takes to get the reduced row echelon form is very similar to the process that we take. Because at the end, everybody's reduced row echelon form is going to have to be the same because you're finding the solution to the system. But your row echelon form, if you've swapped some rows around, could look a little bit different when you're halfway through the process. All right, so let's do some more examples after the break.